Today in class, we learned a little bit about different forms of parabolas, and I just wanted to give a couple more examples for you to work on before you do the assignment. So one of the forms was vertex form, which gives you the vertex, like this form here, a parentheses x minus h quantity squared plus k, where hk is the vertex. And the axis of symmetry is h equals x. So for instance, here's another example along this form. Find the vertex for this particular problem and the axis of symmetry. The vertex is -4, -10, because that's the shift that's going on. The axis of symmetry is always written as an equation. In this case, x equals -4. Don't just write -4. Don't write y equals -4. It's x equals -4. In other words, what we've got is we've got a parabola whose vertex is at -4, -10, and the axis of symmetry is this vertical line that goes right through the vertex. So that's why it's always going to have the same x value as the vertex itself. This and this, they're the same every single time. So that's the easiest form because it allows you to find the vertex without doing any work at all. So the next kind is, let's see, standard form. Standard form is when there's no parentheses, ax squared plus bx plus c. The a and the b are coefficients of the x squared and the x term. So the axis of symmetry is what we find first, the opposite of b over 2a. And then we use that value there to find the y value of the vertex. So I'm going to give these two examples, number 3 and 4, like that. So for instance, on the first one here, the a value is -3, and the b value is +3. That's this thing and this thing. So the axis of symmetry is the opposite of b. Remember, the opposite of b over 2a. The opposite of b would be the opposite of +3, -3, over 2 times a, which is also -3. So in this case, we have -3 over -6, which is 1/2. So the axis of symmetry for this problem is x equals 1/2. Now let me erase some of this so I can get it in a better spot so I can find the vertex. Let's see, I'm just going to move this over. X equals 1/2. All right. Now, to find the vertex for that one, what we're going to do is we're going to take this 1/2 and we're going to plug it into the equation for the x values. So y equals -3 times 1/2 squared plus 3 times, I'm running out of space, sorry. So I'm going to use a thinner pen or something, or put it below. All right, I'll put it down here. Y, and you don't need to see my ugly mug, so let me get rid of this thing too. So y equals -3 times 1/2 quantity squared plus 3 times 1/2 plus 7. I'm putting it in for x here and here. And evaluating, 1/2 squared is 1/4 times 3 would be -3/4. 3 times 1/2 is 3/2 plus 7. So what I've got here is -3/4 plus 3/2, which is 3/4, plus 7 is 7 3/4. So my answer is, the coordinate is 1/2 for the x value and 7 3/4 for the y value. So that's how we do the calculation for that, and that's how we find the axis of symmetry is really the key to it. Now the other one, we're going to take the a and b value, and we're going to calculate the axis of symmetry, and then we're going to do the same thing. So here we go. The a value is 1/2. The b value is -5. So the opposite of b would be +5 over 2 times a. 2 times 1/2. Half of 2 is 1. So the x value is 5 on this one. Now, we're going to take that 5 and put it back in to find out what the y value is. 1/2 times 5 squared minus 5 times 5 plus 2. Well, half of 5 squared would be half of 25. So that's 12 1/2 minus 25 plus 2. 12 and a half minus 25 is negative 12 and a half, plus 2 makes negative 10 and a half. So my vertex is at 5, negative 10. Now, that was how we do the problem with the axis of symmetry and vertex for standard form. The last type of problem that we have, if I can get to it, is the intercept form, where we have the x and x-intercepts. This is the answers for that. You have those in notes already. So y equals a times x minus p. That's one intercept is p, and the other one, x minus q, gives us q for the other one. The p and q are intercepts of the graph, and we find the halfway point between those intercepts by averaging them. Think about what's going on here for a second. If I have a parabola that's like this, and here are my x-intercepts, if I fold those in half, the axis of symmetry is right in the middle, so we have to average those points to figure out where that is. Sometimes you can just count. Once we have the x value of the vertex, we're going to do exactly what we did with the other one, and that would be to find out what the y value is by plugging in. So on the first one, what I have here is an x-intercept of negative 2, since negative 2 plus 2 is 0, and positive 7. So for the axis of symmetry, I'm going to take x equals negative 2 plus 7 divided by 2. Let's see, that would be 2.5. Like 5 over 2 is 2.5. So therefore, the vertex is at 2.5 something. Then we're going to take that 2.5 and we're going to plug it into each of those parts, and we're going to see what it is. So let's see. 2.5 plus 2 is 4.5. 2.5 minus 7 is negative 4.5. You'll notice that you're always going to get the same two numbers in those things, where one is positive and one is negative. 4.5 times negative 4.5, I just happen to know, is negative 20.25, or negative 20.25. All right, now let's try the other one. We've got an x-intercept of 1 and an x-intercept of negative 3. If I average 1 and negative 3, I'm going to get negative 2 divided by 2, which is x equals 1, which my x value is going to be 1. Lastly, we're going to take that x value in and we're going to put it in for x. So negative 3 times negative 1 minus 1 for the first parenthesis, negative 1 plus 3 for the second parenthesis. And just like before, we'll notice that this is negative 2 and this is positive 2 times the negative 3. So 2 times negative 2 is 4. Negative 4 times 3 is positive 12. And that gives us the vertex for that second one in intercept form. So we've got vertex form, we've got intercept form, this one, and we've got standard form. And you've got examples for all of them now. So I'm hoping that you can figure out what's going on.